Hi everyone. We're going to talk a little bit about two subjects that at first don't look like they have much to do with each other. These are the subjects of average value and symmetry. Before we can talk about those, I need to just explain one point that you may have seen from an earlier Calculus 1 course. In order to find this area, it's useful to view this as the area between two curves. Some of you may have learned the rule that when the curve lies entirely below the x-axis, then the area between the curve and the x-axis is equal to the negative integral. That's true. It's just not a very useful way of thinking about it because it's better to derive it from the general rule. What you want to do instead is think about this, that the pink area is actually the area in between the x-axis, which is y equals 0, and the curve y equals f of x. So now the x-axis is just the top curve, and the curve f of y equals f of x is the bottom curve. We can now just do some algebraic simplification. And you now see the rule that some of you learned, that when the curve lies below the x-axis, the area is given by the negative of the integral rather than just the integral, as we've done with curves above the x-axis. A fairly common wrong statement is that when the curve is below the x-axis, the area is negative. Area is actually never a negative number. Area is always a positive number. There's always a positive amount of area. It may just be that if the integral is of a function that's below the x-axis, in order to find this area, we may get a negative integral and have to multiply it by -1. That means the integral is negative, but the area that it represents is positive. So this brings me to the topic of even and odd functions. An even function is one where f of -x equals f of x for all x where the function is defined. An odd function is one where f of -x equals negative f of x for all x where the function is defined. Let me show you what these look like. So for an even function, if I pick an arbitrary number a and find its mirror image on the other side of the y-axis, plug it into a, I should get the same y value. On the other hand, with an odd function, if I plug in a and negative a, I should get equal but opposite values. So in one case I get a particular y value, in the other case I get that same y value multiplied by -1. Now here's the point. Take a look at what happens if I find the area between this function and the x-axis, in the case of both the even function and the odd function. In both cases, although I haven't really drawn this very well to scale, the point is that in both cases the yellow area and the pink area for each function are equal to each other, but the integrals, in the case of the even function, since the function lies entirely above the x-axis in this case, we're getting a positive area for the yellow part and not a positive area. Area is always positive. We're getting a positive integral for the yellow part and a positive integral for the pink part, whereas for the odd function, we're going to get a negative integral for the yellow part and a positive integral for the even part. So take a look at what happens when I actually form these integrals. In the case of the even function, I can simply double one side because the two sides are equal to each other and they both have the same sign. So in the case of the odd function, when I break it up into the two sides of into the two sides, -a to 0 and 0 to a, I get two integrals that are equal but opposite each other, which means that they just add up to 0. So this is the rule, is for even functions, when you integrate from -a to a, you get 2 times the integral from 0 to a of f of x dx. And on the other hand, with an odd function, when you integrate from negative a to a, you simply get 0. I'll just put the rule up there. Okay, so there are a couple of things that you have to know about even and odd functions that make them a little bit easier to identify and work with. So first, sine x is an odd function. Next, cosine x is an even function. Third, f of x equals x to the n is even or odd depending on whether its exponent is an even integer or an odd integer. In fact, that's where the terms even and odd come from. So for example, f of x equals x squared is an even function, f of x equals x cubed is an odd function. Let's use the algebraic definition of even and odd to evaluate whether certain functions are even or odd. The way that you evaluate whether a function is even or odd, or neither, by the way, it's possible for a function to be neither even nor odd, but the way you evaluate it is you evaluate f of negative x and see if you get either f of x or negative f of x. If one of those comes out of the algebra, you know the function is either even or odd. So let's try it. So it seems that f of negative x equals f of x. In other words, this is an even function. Let's try another one. As usual, we start by simply plugging negative x into the original function and seeing where the algebra leads us. As we see in this case, g of negative x is equal to negative g of x, so this is an odd function. Let's try a third example. As usual, we start out by evaluating the function at negative x. This expression is not equal to either the original function h of x or to its negative. This is not equal to either x squared plus x cubed. That was h of x, and it's also not equal to negative x squared minus x cubed, which would have been the negative of h of x. So this is a function that is neither. So let's show how to use even and odd symmetry to evaluate an integral. The integrand here, as you can see, it's not going to be either even or odd. We already can see that it has an x squared and an x to the 37th. It mixes even and odd functions, but that doesn't mean that we can't use symmetry to evaluate it, possibly. What we really need to do is first figure out is tan x even or odd or neither. Well, if you recall what tan x looks like, it certainly looks odd. But let's verify algebraically that tan x is in fact odd. So using the properties we already know about sine and cosine, we know sine is an odd function and cosine is a negative function, so we can use that in the calculation. We see the tangent of negative x is in fact equal to negative tan x. So tan x is an odd function. Now, here's what you do. We break the integral up into its even parts and its odd parts. The odd part, of course, we know is just going to be equal to 0. We then use the property of integrating an even function from negative a up to a to simplify the integral even further. And we get an answer of 250 over 3. So this very complicated looking integral, it turns out, can be simplified using the properties of even and odd symmetry.